Now we are ready to start looking at rationalizing denominators. This is a very important concept and you must learn it excruciatingly well because if you take calculus, you will also have to rationalize numerators. Rationalizing denominators is actually the process of rewriting a radical expression as an equivalent expression in which the denominator no longer contains any radicals. That is what we mean when we say rationalize the denominator. No radicals to be left in the denominator. Now, there are two different kinds we're going to have to look at. The first and simplest one. If the denominator consists of the square root of a natural number that is not a perfect square, that means it is a simple number. There's no adding or subtracting in the denominator. Okay, if that's the case, we're going to multiply the numerator and the denominator by the smallest number that produces the square root of a perfect square in the denominator. Now, any number that would make a square would do. It doesn't have to be the smallest, but why complicate matters? Radical expressions that involve the sum and difference of two terms are called conjugates. So the square root of a plus the square root of b and the square root of a minus the square root of b are called conjugates. 3 plus the square root of 5 and 3 minus the square root of 5 are conjugates. 2 plus the square root of x and 2 minus the square root of x are conjugates. Now the reason I say this is for the second type that we're going to have to work with when the denominator contains two terms with one or more square roots. If that's the case, all we have to do is multiply both numerator and denominator by the conjugate of the denominator. Now again, by multiplying numerator and denominator by the same number, we're actually multiplying by 1. We're not changing anybody's value, but boy, are we changing the way it looks. So let's take a look at an example of each type. In the top example, I have the square root of a natural number, where in the bottom example, my square root's still in the denominator, but he's part of a sum. The two different methods. The one that is simple, I simply multiply both numerator and denominator by that radical. So my numerator becomes 5 square roots of 3. And my denominator, the square root of 3 times itself, is just 3. That is my final answer. It is in simplest form. Let me stress again, if this were 6 square roots of 3 over 3, I could divide the 3 into the 6. That works. But that is not what I have. And the square root of 3 over 3 cannot be simplified. This 3 has an exponent on them, the 1/2 power. This 3 doesn't have that exponent, so there is nothing that you can do with that. Do not ever try to simplify that. And the last example there, 8 over 4 plus square root of 5. I have to rationalize the denominator because in algebra they tell us our final answers cannot have radicals in the denominator. So, in order to rationalize it, I make a conjugate pair. Since they had 4 plus square root of 5, I want 4 minus square root of 5. Now again, I'm going to write a lot out. You need to start learning to skip certain steps. So I'm not going to actually write out the top and bottom, but I am going to say them. My numerator is 8 times parentheses 4 minus square root of 5. So I'm going to distribute the 8 through for my next step. 8 times 4 is 32 minus 8 times the square root of 5. And if you haven't practiced enough multiplication to know, conjugate pairs give the difference of squares. If you FOIL this out, every time you get the front guy squared minus the back guy squared. The outer and inner terms are always opposites, and therefore when you add them together, they seem to just disappear. So it's the front guy squared minus the back guy squared, the difference of squares. And so my answer here becomes 32 minus 8 square roots of 5 over 11. Now, how do you know how to leave your answer? My honest opinion is I don't know. You check the answers if it's multiple choice. I would stop here because most multiple choice tests are timed. So I would stop here and look for their answers. If it does not look exactly like that, it will probably look like 32 over 11 minus 8 over 11 times square root of 5. Final answer.